Okay, here on the second page, we're not going to do number 8, so you can cross that out. I'm going to work out 4 and 7, and I'm going to let you guys do 5 and 6. So 4 and 7 do have a little bit of a different feel, a tiny bit, just a little bit of a different way to ask the question. So let's look at 1.25 feet, or no, 1,250 feet tall. Okay. If the penny's pathway can be modeled by this equation, negative 16t squared plus 1250, how long would it take a penny to strike a 6-foot tall person? Okay, so let's draw this picture here. So I'm on the Empire State Building and I throw a penny off of there. All right, and the penny's gonna go up and then fall down. All right, so, or no, it's just dropped. So it's going to look like this. It's just going to go like that. Okay. Now, when we were doing how long it would take for the ball to strike the ground, okay, what did we let y equal or h equal? We always let h equal 0, right? We let it equal 0 because that was going to be the height when it hit the ground at 0. But now they don't want it to hit the ground. They want to know at what time will it strike a 6-foot tall person. So maybe right there. So instead of letting h be 0, okay, because 0 is where it would be at the ground level, where would it be when it's at 6? Okay, so in this problem, instead of letting h be 0, we're going to let h be 6 because I want to know at what time will it reach 6 feet from the ground. Okay, so we'll have 6 equals negative 16t squared plus 1,250. Now, when you're solving a quadratic, okay, it's really nice when you only have one term that has a t, right? And the other ones, you always have the t squared and the t term. When you only have a t squared term, we can use that square root method, right? Isolate the t squared, all right? Isolate the t squared and then take the square root of both sides. So I'm going to subtract the 1,250 from both sides. Okay, so I'm going to get that. I'm going to switch this around too. Negative 16t squared is equal to 6 minus 1,250 is negative 1,244. Okay, now let's go ahead and we'll divide that by negative 16. Divide each side by negative 16. I'm running out of room. I'm going to write a little bit bigger. So I get, those go away. I get t squared equals, punch that into a calculator, you get roughly 7.75. Now, let's go ahead and take the square root of both sides. Now, before we took the positive and the negative of the square root, right? When you take the square root of both sides, you have to say plus or minus the square root of 77.75. But here we're talking about time again, okay? Does it make sense to talk about a negative time? No, it doesn't make sense to talk about a negative time. So here I really am going to only care about the positive solution. So I'll just ignore doing the negative right now. So the square root of t squared is just t equals, put that into a calculator, you're roughly, I'll do a little squiggly one, going to get 8.82 seconds. Okay, so if you throw a penny off the Empire State Building, it's only going to take 8.82 seconds for it to hit a 6-foot tall person. Okay, now I would imagine for it to hit the ground, it won't be too terribly, too much more. I would guess probably less than 9 seconds. Okay. But you can check it out if you want to see. Okay, I'm going to leave 5 and 6 for you. Now 5, be careful. You have to read exactly what it says, okay? 5 says, how long does it take for the firework to reach the ground? So that means you're going to be finding the solution. So set it equal to 0. factor, okay? And then you can solve by setting each of your factors equal to 0. Okay, and then on number 6, they want to know what the maximum height is. So when you're finding the maximum height, you're finding the y-coordinate of the vertex. Okay, all right, and then so finally, number 7, Eva is jumping on a trampoline. Her height h and time t can be modeled by this equation. Would Eva reach the height of 14 feet? All right, so if you're thinking about Eva bouncing on a trampoline, okay, she goes up, she goes down, she goes up, she goes down. They want to know, will her maximum height reach 14 feet? Okay, or if she'll reach 14 feet, maybe she'll reach 16 feet. I don't know. But if I want to talk about how high she's going to go, let's find her maximum height. Okay, so we're going to be doing, just like you're going to be doing in problem 6, finding that y-coordinate of the vertex. So you got to first find the x. X equals negative b over 2a. Negative b is a positive 20, all over 2 times negative 16. And that is going to give me approximately 0.625, or actually exactly 0.625. Okay, so that's the x value, okay? That's going to be the time. So it only takes her less than a second to reach her maximum height on a trampoline, okay? Now to find the y, or I should have said this should have been the t and the h, okay? To find the h, we need to plug that into my equation. 0.625 squared plus 20 times 0.625 plus 6, and that is going to give you, punch that into a calculator, approximately 12.25 feet, okay? So we're talking about the height now. So the question is, if the maximum height is 12.25 feet, is she gonna reach 14 feet? Well, no. The highest that she's gonna get is 12.25 feet. Okay, she won't reach that 14. So the answer is no. Okay, she'll only reach the 12.25. Okay, so go ahead. You got number 3, which has both parts, finding the maximum height and the time. And then 5 and 6, you only have to find one of those parts.